Okay.
All right.
So when you look at this memory aid, um, you see the W1, W2, W3, W4, V2, V5. Those, whenever you're asked a question that says ground distance covered during climb, and it's asking for you to reference W1 or W2, W3, W4, those are the answer selections. So there's always three answers that you can choose from. So your answer is going to be either the middle, low, or high. Does that make sense?
Yes.
So whenever it asks you a question on, what is the ground distance covered during climb using W1, and when it asks for W1, it's asking for the question that is telling you to refer to these different charts using the W1 information. That will be your answers, the middle answer.
Man, I wish I would have brought that home.
Yeah.
I can send you.
Oh, go ahead.
I was going to say I can send her a copy if she wants one.
Oh no, I'm back at my desk tomorrow. I had today off, but I'll be back at my desk tomorrow and I'll just bring it home.
But yeah, then like figures 74 and 75. So remember, this is the aerodynamics and aircraft. What did it say? Aerodynamics and aircraft something or other section. So when you're in that section, and so if it's asking you about figures 74 and 75, and the pounds that it's telling you to use is 90,000 pounds, you choose the high, right? 90,000 pounds, the high. 100,000 pounds, low. And all the way down.
When you're talking about high versus low, are you talking about the highest value?
Yes.
Okay.
Yeah, exactly. So the highest value is the one you're going to select, or the lowest value, that's the one you're going to select out of the three answers possible.
I've had this thing for 6 weeks, and that's the first I've understood that what this sheet is showing.
Oh, okay. Sorry. So this time to alternate, if it's asking for a time to alternate and its distance that it's listing is 50 nautical miles, 110 nautical miles, those are the values you're choosing. Okay. So what I would do to help me memorize this time to alternate section, I would know that all the answers except for when it asks me the 330 nautical miles are going to be high. When it asks me the 330 nautical miles, it's going to be the lowest. Okay.
Is the order of the multiple choice answers going to be randomized on the test?
Yes, it is. So can you, Tyrell, can you pull up your Shepherd Air program? Okay.
Is there a certain section you want me to go to?
No, this is fine. Okay, so can you give me your control of your mouse?
Sure. How do I do that?
Just on the right side in the control panel, just where it says give mouse and keyboard under screen sharing, and then just give it to me.
You should have it.
Okay, cool. So this question is asking, what is the maximum allowable weight to be carried on a pallet, which has the dimensions of this? And you can see here that it's referencing the memory aid, right? So whenever you see this memory aid thing pop up, that means that the memory aid will have the answer. So if we go down to weight and balance performance here, Let's see. Wonder if it's. Can you scroll down real quick? For some reason, it's not liking me to scroll. So keep going. Okay, right here. So scroll up just a little bit. Right there. So it's just that weight and balance at the top so I can see all the. Sorry. Okay, so here's your clue for the section. Okay. What is the maximum allowable weight carried on a pallet? If the answer choices are all greater than 1,000, then the correct answer is low, except for the one that has 1,611.6 pounds in it. If all the answer choices are less than 1,000, then the correct answer is mid, except for 914 pounds. So if we pull up this flight test right here, let's see.
It's not going to give you all of the answers unless you're in the test mode.
Yeah, can you go to the, okay. There you go. So all the answer selections here are above 1,000 pounds, right? So if we go to this, greater than 1,000 pounds, then the correct answer is low, except for 1611.6 pounds. Okay, so none of these have 1611, but they're all above 1,000. So I'm going to choose the lowest answer, and that's the correct one, right? The one's 1663.2 pounds. Super easy, right?
I have to tell you that when I was doing these, and rather than going to the memory aid, it was a lot easier to use a calculator and find out what the actual weight was.
Yeah.
Just because once you learn the technique for it, you can do this one in probably 20 seconds.
Yeah. And honestly, I did all the pallet calculations. I figured out how to do them real quick, and then I was set. I didn't do the memory aid. But for those of you that don't like math, and had I actually read this, I probably wouldn't have figured out the actual equation. But it's pretty simple to figure out. So you got to figure out the actual size. You got to take these 42.6, multiply it by 48.7, and divide it by 12. That gives you your square footage.
Divided by 144.
Oh, I'm sorry, 144. That's right. Because a 12 by 12 inch, so 1 foot square is going to be right. So 42.6 times 48.7 divided by 144, and then let's see. Then you multiply it by the 121. Then you subtract the pallet weight and the tie-down devices. So add those two together and subtract them from the total that you get here, and that's your answer. Do you mind if I pull up your calculator, Tyrell?
Yeah, that's fine. I can do that for you.
Okay, so let's just show you guys that. Let's prove it out really quick. So 42.6, multiply that by 48.7. Okay, that's your square inches. We got to convert it to feet. So we divide it by 144. And that gives us 14.407 square feet. Okay. So if we multiply that by 121, and then we subtract the pallet weight, and then subtract the tie down devices, there you go, 166 or 1663.26 or 1663.2. Pretty simple, right?
To me, it was a lot simpler than trying to memorize this.
I agree.
So, I mean, either way, whatever floats your boat, do it the way that's going to work for you. But here's two examples of how to do it. If you can just memorize that all of them are the low answer except for 1611.6, or if it's less than 1,000 pounds, all the answers are the middle answer except for when you see 914.1. Cool. When you see the 914.1 or the 1611.6, that's the answer. Okay. But yeah, this memory aid, super helpful.
Is there any way we can bribe them to let us take this in?
Yeah, you can try. But the part that I suggest you guys really use this memory aid would be this flight planning. It makes it super simple to do the flight planning section. Let me see here. But here's also this map here will help you pretty well as well. So when you have, wow, that is not where Minneapolis is. That's funny. Okay, so you can see that the city pair here is Denver and Minneapolis. Whenever it's asking you to do anything about the flight plan to do with Minneapolis and Denver as the city pair, then the time is always going to be the lowest and the fuel is always going to be the lowest. Okay. And then same here. St. Louis to LaGuardia, time's always going to be high, fuel's always going to be mid. Okay. Super simple. But that's what I'd use this memory aid for. Any other questions on how to use this memory aid?
So you, at some point, not tonight obviously, but at some point, would you review maybe some of the flight planning when we're in class together, for example, for the that actually goes onto the test, so that we can understand how all of these things relate. And I'm going to suggest before the class, because I'm actually scheduled to take the ADX prior to. And I'd be happy to do that, one-on-one in an online meeting if possible.
Yeah, I mean, we could do that for sure.
Or when you're in town, I'll take you to dinner or whatever.
I'm good for anything. Yeah, we can.
And then
we can
anyone who wants to join is welcome to.
But yeah, I mean, a lot of this ADX. It's painful, but once you get it over with, it's like a huge weight off your shoulders. Everybody that I've asked that's taken the class before is. So I always ask, what would you recommend to future students? And all of them are like, get the ADX done. If you can't do it before class, get it done before the 2 weeks of flight planning, because when you're trying to do everything at the last minute, it makes everything harder to do. So, but yeah, that'll help you guys. Um, yeah. Tyrell, can
Yeah.
you? I don't know how to unmake you the presenter. Is there something on your screen that?
Yeah.
There we go.
Does that work?
Yep. All right. Well, I hope that was helpful for you guys. Um, all right. Well, let's get going on these TAFs and METARs. So tonight we're going to focus primarily on TAFs. The good thing about the TAF is that the TAF and the METAR use the same abbreviations. So that'll help. That should help quite a bit. The METAR is kind of the main one because you get a lot more information in a METAR than you do in a TAF or any other weather report. So. Let me see. KSFO. Start naming some airports. Well, how's the weather in St. George right now?
Partial cloudiness. Mostly clear skies.
Laramie. Reno might have something fun. Eugene. Idaho Falls. Ooh, there's some fun stuff down here. Let's do Shreveport. Let's do Pensacola. Mobile. All righty. Let's see. We'll just pull up TAFs for now. Do I need to zoom in? I'll type. All right. Let's see what you guys remember from METARs. Who wants to start up here? Who wants to give
Is this TAF or is this METAR?
So this one's this one's a TAF, but it's very similar to a METAR. This is basically a METAR up to where the temperature dew point spread is. Just a little tiny bit different. Come on, y'all, don't be shy.
Well, we didn't do any TAFs at all yesterday, so
I know, but like I said, it's basically a METAR up to the point where the temperature dew point spread is.
I can do the parts I understand.
Yeah, yeah, take a stab at it.
So it's out of Salt Lake City on the 23rd at 23:23 Zulu. I don't know what the next numbers are.
Okay, we can skip them.
But then the wind is coming from 240 degrees at 12 knots with 18 knots for the gust. And I don't know what P6SM is, but then light rain showers. Scattered clouds at 7,000 feet and broken clouds at 10,000 feet.
Okay, where's your ceiling in this?
The ceiling is, I don't know.
Can you define a ceiling?
The ceiling is where the clouds are, so that would be the 7,000 feet.
Nope. So the lowest layer of broken or overcast clouds.
Oh, broken, so 10,000.
So broken, 10,000. So that's where we would define the ceiling is 10,000 feet.
Gotcha.
Good, you did really good. So this, let's go through the TAF now. Like I said, it's a lot like a METAR, just a little more simplified because it's a forecast. This isn't. Remember, a METAR is what is currently happening over the field. Okay, TAF is what is expected to occur over the next approximately 24 hours. Okay, so so this TAF is a corrected TAF. COR stands for corrected. Another thing that you might see is, let's see if we can find it real quick. Okay, none of them are. Oh, let's Sorry, where did it go? Okay. So this is a corrected TAF. The other thing that we might see here is just like a METAR, you might see AMD, which stands for amended. So this means that something changed significant when it's amended, it means that there's been a significant change in one of the categories, whether it's winds, visibility, or sky condition. Okay. That wasn't forecast, it wasn't expected to be happening over the next day. A corrected is just when they go in and make a correction. Maybe they were missing something. They just go in and they'll just make a quick correction to it. So this is a corrected TAF. Like I said before, the other type we'll see is an amended TAF. Okay, this is for Salt Lake City. This is our airport identifier. And then, like you said, this TAF was issued the 23rd of this month at 23:23 Zulu. Okay. TAFs, and I want you guys to write this down. This is super important and super valuable. Okay. For all aspects of dispatch, whether it's a test, practical, whatever, interview, or when you're actually dispatching. TAFs are issued every 6 hours, 4 times a day. Okay, every 6 hours. The scheduled times for TAFs to be issued are 0000 Zulu, 0600 Zulu, 1200 Zulu, 1800 Zulu, and that's it. Okay, 00. Once it hits 1800, I'm sorry, I made a mistake there. Not 18, 20Z, not 18.
Can you repeat all of that one more time?
No,
what you want us to
that is 18 Zulu, sorry. Okay, so TAFs are issued 4 times a day, or you could say TAFs are issued every 6 hours. Okay, so write that down. That's number one. The scheduled times for the TAFs to be issued would be 0000 Zulu, 0600 Zulu, 1200 Zulu, 1800 Zulu, and 24. Well, 24 is 0000. So those times again, 0000 or 2400, whatever you want to write there. But midnight, right? Then 06, 1200, 1800.
And that's for those airports in that particular geographical location and the Zulu time there, correct?
So Zulu time is universal time everywhere. And yes, it is for every single airport that has a TAF issued for it. Okay.
Now, when you say Zulu time is the same everywhere, our Zulu time is different from New York's Zulu time right now, is it not?
No. So Zulu time is the universal time. So Zulu time, no matter where you are in the world, it is the same exact time.
I think I just lost about 15 years of brain power right now.
Yeah, that's why it's the universal time. That's why we use Zulu time, is because no matter where you are in the world, it is using the Greenwich Mean Time. So the time clock in Greenwich, England, that's what everything is set to. That is 0 hour. That's Zulu hour. Okay. So in aviation, every forecast, every NOTAM, every flight, It's all scheduled in Zulu time. Now, I don't want to confuse you, but
Sorry, you already have. We're way past that point.
yeah. So everything's in Zulu time. When it says 2300 Zulu in New York, if they looked at this and saw 2300 Zulu, it'd be the same. You can see here, this TAF for Seattle was issued the same exact time for Salt Lake City. San Francisco, we've got Shreveport, Louisiana, 2300 20 Zulu. Mobile, Alabama. So Zulu time is, no matter where you're at in the world, we're all using the same time clock. Okay, so our deviation from Zulu time is of course going to change. That's just, if you're General Mountain Time, or if you're Pacific Standard Time. Those are the time zones. Those are the different times, and we can subtract. So we subtract from this for General Mountain Time. We'll subtract 6 right now because we're in daylight savings time. So if we subtract 6 from that, that's what time it is local. If we subtract 7 from it, that is LA time or Pacific Standard Time. Does that make sense?
Yes, I'm glad I finally got that straightened out.
Yeah. So no matter where you're at in the world, the TAFs are always going to be issued at the same time, which really sucks when you're dispatching, because you'll be dispatching and all of a sudden at 6Z, you get a huge list of all the airports when we're dispatching, all the airports that we're dispatching to, that throughout the day, whenever TAF time comes, we just get this huge list of all the TAFs that have been updated that we've got to go through and make sure that all of our flights are still legal. Meaning they don't need an alternate, or they do need an alternate, We've got to go through and verify that everything's good before our planes get off the ground. So yeah, just remember, issued 4 times a day, 6Z, 12Z, 18Z, and 24/0Z. So you can see here, they don't always issue them right at 2400 Zulu. That just means that they've got to issue it around that time, okay? And it's the same with the METARs. The METARs are issued hourly, but that doesn't mean that that everybody puts their METAR out at the same exact time. It just means that within a small window, they need to be issuing a new METAR. Okay. So TAFs, this is a 24-hour forecast, basically. You can see here, this is what we call a validity time. This is our valid time. Okay, so from the 23rd at 23Z, because this was issued at 23Z, so from the 23rd at 23Z until the 25th at 06Z, this is valid. We can use this TAF if no other TAF comes out in this time period. We can use this TAF, will be valid for that entire time period. Does that make sense? There's some outstations like Minot or Houghton Hancock. I think that's how you Houghton Hancock, where we don't get a TAF every 6 hours from them. So if we get a TAF for Houghton Hancock, this valid time is pretty important. Okay. So the valid time is what's going to determine, is this weather still a legal source to look at? So we just check that really quick to make sure that this is a valid TAF, that they're not spitting out old data. Okay, this is our winds, 240 at 12 knots, gusting to 18. So that's how I want you guys to read them. This is your wind direction, 240 at 12 knots. The G stands for gusting, and 18 stands for gusting to 18 knots. Okay, so 240 at 12 knots, gusting to 18. The P here stands for greater than. Okay, plus, greater than, whatever you want to do to remember that P stands for greater than or more than. Go for it. But greater than 6 statute miles of visibility. So this is our visibility. You did really good here. This means the funny thing about METARs and TAFs is if we have a intensity indicator and then we have a description like showers, we'll skip the description and we'll start with the intensity. So intensity is light, rain, and then showers. Does that make sense? So they'll always put the intensity, then the description, and then the precipitation occurring. But we read it as light rain showers because you can't have light showers of rain. That just doesn't sound correct, right? It's light rain showers. Okay, scattered at 7,000, broken at 10,000. The next thing we look on the TAF, this next line, is a from line, okay? We call them from lines. So from the 24th at 0015 Zulu, this is the change, okay? So here's what's important to remember. Gosh, I hate how it does this. Okay, here's what's important to remember. This TAF line right here is good from this 2300 Zulu here until this time right here. Okay, actually the minute before. So that means that that first line, all this right here, is valid from 23 Zulu until the 24th at 0014. Because once it hits 15, then this is the valid line right here. So until this date and this time, this is the valid weather. Did that make sense at all?
So the first line is only good for just less less than an hour. Is that the way that's reading?
Yep. Exactly. So, you know, when I was talking about the TAF issue time and said that TAFs are issued every 6 hours, do not correlate the TAF issue time to what these times should be. Just because it's issued every 6 hours does not mean that the forecast is going to go step out every 6 hours, okay? Like you can see here that even though this is a 24-hour TAF, you can see that this one steps out, and you've got in that 24-hour window, we've got 1, 2, 3, 4, 5, 6 different times that we're looking at. So what is written in these TAFs is just when they expect a significant change in weather. So when the forecast changes, this is when they're expecting things to change. Okay. There's a significant enough change in the weather that they start a new line. So this first line, yeah, it's good for basically 45 minutes, let's just say. So that's good for about 45 minutes, but then you can see that from 00:15 until 1, that's another 45 minutes. But from 1 until 1800 Zulu, they don't expect a change. Or 1900 Zulu, I'm sorry. So from 1 until 1900 Zulu, they expect the weather to stay about like that. And then from 1900 Zulu until the next day at 0300 Zulu, it's going to be this weather. Does that make sense at all?
So this is kind of like a brief forecast that gives us an idea, but is not the ultimate say when it comes to dispatching to Salt Lake City.
So, yes and no. This is a forecast. In fact, TAF stands for Terminal Area Forecast. So this is like the weatherman jumping on the news. How correct is the weatherman? In St. George, I'm sure they're correct most of the time because St. George weather is always about the same. Either really freaking hot or really windy. Rarely rains, right? But in Salt Lake and in Denver, San Francisco, the weatherman's right about 20% of the time. So that's what we take this as, is a grain of salt, as far as like, what is the weather actually going to do? But this is the say-all for dispatching. 100%. This is the only forecast that we use when we are dispatching. Well, we'll use the METAR as well, but the METAR, once again, it's only valid for an hour. And so if our flight time is less than an hour, then we have to refer to the METAR for legalities. But the TAF is always going to determine, are we legal to go, or do we need an alternate? So and we'll right now I don't necessarily want to get into legal to go or doing an alternate. So we'll learn how to read a TAF, and then we'll start talking about legal to go, and then we'll go into do I need an alternate? Okay. So that being said, who wants to read Boise here? Don't be scared.
I'll try it.
All right.
Okay. It's a TAF for Boise on the 23rd at 23:33 Zulu.
Oh, gosh, my computer is being stupid. Sorry about that. Go. Go ahead.
I know how it feels.
Sorry, I'm trying to charge my iPhone, and for some reason it keeps popping up all this iTunes crap, kicking me out. Okay, there we go.
Do you want to take a break before I do this?
No, you should be good now.
Before I embarrass myself? And again, all of a sudden, I shouldn't have volunteered because my brain is like, I feel like I'm in the middle of a migraine right now with no ability to concentrate. But the 2400 to, is that the 24th at 0 until the 24th. So this is a 24-hour, basically 24-hour. Okay. Winds at 130 degrees at 4 knots. And then greater than 6 miles, 6 statute miles visibility. VC and SH showers. Is that? Sorry,
You're good. So VC stands for vicinity, in the vicinity.
See, normally that didn't we see them before as VCN or something like that?
I'm not sure. I don't remember VCN, but yeah, whenever we see VC, we just always. I think in the METAR it's even VC, but that just means that there's showers in the vicinity of the airport.
And then scattered clouds to 10,000 feet.
Mm-hmm. Good. So yeah, this is kind of written out weird as far as this 24 to 24. So this is just saying from midnight to midnight. This should say 25. It shouldn't say 24, but 25 is 00. But for some reason, they decided to write it out like this. But good. You did good there.
It's a little bit like my wife. She doesn't want to be 60 next month, and so she's decided. I told her just be 50-10.
Yeah, exactly. It's a lot easier to swallow right there, right? But yeah. So here's the next thing that we need to learn about is these temporary remarks. Okay. So this line is valid, or this line is valid from this 2333 Zulu until 0259 Zulu. Okay. That's where this valid, or this line is valid. This is the forecast for that time period to 0259. Then this line is valid from 3Z all the way until this 24Z. Okay, we call this the main body, and then this is what we call a temporary. Okay, all that a temporary is it means that sometime between this line and this line for a temporary amount of time, from the 24th at 00 Zulu until the 24th at 0200 Zulu, that they're expecting light rain and thunderstorms, and for it to be broken at 5,000 feet with cumulonimbus clouds. Okay, so you can see that the valid time of this temporary remark doesn't take up the validity of this entire of that entire time period between your main body here and this main body. Sorry, this main body. Just means that for a short amount of time between the two, they're expecting thunderstorms and the ceiling at 5,000. Okay. So basically, if it's outside this window, then we refer back to the main body here. But during this 00 to 02, then we refer to the changes here. So the winds, you can notice that it only changes two things, right? Really one thing. But the wind will still be expected to be 130 degrees at 4 knots, and we're still expected to have greater than 6 miles of visibility. But rather than vicinity showers, we're expecting a light rainstorm with or light rain with thunderstorms over the field. And we're expecting, rather than scattered at 10,000 feet, we're expecting broken at 5,000 feet with cumulonimbus clouds. But once we're at 0200Z, from 02 to 0259, we refer back to this line. Does that make sense? Did I lose everybody?
It's slowly sinking in for me.
So let's come down here. Who wants to read this?
I can take a crack at it. So you're just wanting the from that time frame?
Yep.
So it's on the 24th at 0600 Zulu time. And it's at a heading of 220 at 10 knots and greater than 6 statute miles of visibility with scattered clouds starting at 20,000 feet.
Okay, close. So wind direction, like you said, 220 at 10 knots. This is scattered at 2,000 feet.
2,000. Okay. Yeah.
Yep.
It would
So
have to be over one more place for 20,000.
So
okay.
So all we ever do is they always just drop off the last two zeros here. Oops.
Okay.
For every one of our reports, TAF or METAR, they just drop off the last two zeros. So if that's 2, then it'd be 20,000. If it's right there, then it's 200 feet. So
Then temporarily, the from 06 Zulu to 09 Zulu on the 24th, you're going to have broken. You're going to have a broken ceiling at 2,000 feet.
mm-hmm. So something interesting here. So you guys remember how I said that this isn't always going to take up the entire window? You can see that this one does, right? So 06, 09 is our next line. All it's saying is that sometime for a temporary amount of time, this scattered layer is going to turn into a broken layer for a short, they're expecting it to turn into a broken layer for a shorter amount of time. Does that make sense?
Yeah. So basically, between the two settings, at some point in time, the scattered clouds are going to turn into broken clouds.
Uh-huh. And it's just for a short amount of time. They're not expecting it to last the entire forecast window. Just at some point for a short duration, they're expecting it to turn to a broken layer. Good. Man, the weather's not as bad as I was thinking it was. So here's an interesting one. This prob 30. Anybody want to take a stab at what prob 30 would mean?
Probability at 30%.
Uh-huh. Exactly. So there's a probability. Sometimes we'll see tempo, sometimes we'll see a prob 30, sometimes we'll see a prob 40. Okay? So all it's saying is that there's a 30% probability that in this forecast window, they're expecting, just like how we would read a temporary, between 18 and 24, they're expecting it to change to 4 miles visibility with rainstorms, rain and thunderstorms, and a broken layer at 2,500 feet of cumulonimbus clouds. So, why do you guys think it'd be important to list what type of cloud that cumulonimbus is? Like, why don't we see, when it says scattered 1,500, why don't we see stratus or cirrus clouds identified?
Because there's no rain probability there.
Okay, maybe a little bit to do with that. What's the difference between a cirrus cloud and a cumulonimbus cloud, other than rain? Let's say a cumulus cloud.
You're talking about wind.
Wind, and what else? One of my favorite words when we're talking about weather.
Microburst?
Nope. It's like an oven, a special type of oven.
Convection.
There we go. Okay, so convection, right? Whenever we see cumulonimbus, we automatically need to turn our brains to convection and rain, right? So cumulonimbus means that it's a convective cloud and that it's rain bearing. Remember, the cumulus clouds are the really fluffy marshmallow clouds. The clouds that you draw as a little kid that were the big old puffs, right? Stratus clouds are just that kind of blah. It's like a blanket. Nondescript clouds that just cover the sky. Cirrus clouds are like the real wispy mare's tails that you see up high altitudes, right? So cumulus clouds, though, with that fluffy appearance, is because of the convection in the air. That circulation of air is causing turbulence. Some of the things that we can see associated with that are going to be things like wind shear, gusty winds, storms. We may see these thunderstorms pop up, the TSRA. We're going to probably associate that with a cumulonimbus cloud. Okay. There's two other types of clouds that we'll ever see on a weather forecast. That would be a towering cumulonimbus. Okay. And then the other one would be an altocumulus standing lenticular. So ACSL. So if you ever see those are the cloud types that are identified in these weather forecasts, and we need to think back to why they would be identified. So towering cumulus, same reason as a cumulonimbus, right? What about an altocumulus standing lenticular? What characteristics do those have?
Wind shear.
Mm-hmm. It's also a lot to do with the turbulence, right? So remember, where do we typically see those altocumulus standing lenticulars? I'm making you guys dig deep.
I just want to give somebody else an opportunity, so I'll hold back.
Hold on, sorry. Sorry about that. So anybody able to think of it? Here's a hint.
Mountainous terrain.
Mm-hmm. So we tend to see them over mountainous terrain on the leeward side of the mountain, right? So what's the leeward side? What's the windward side?
The wind hits the windward side and then cascades down the leeward side.
Exactly. So if we have wind coming up this direction here, and then coming down this direction here over the backside of the mountain, what happens is sometimes we get this little swirl here, right? The wind will just kind of swirl right here. Well, what happens is we get these clouds that look like a lens. Remember, the altocumulus, standing lenticular, just kind of look like a contact lens sitting on the backside of the mountain there. So what's happening is we've got real high-speed winds coming up over the top of this peak, and as they come down this side and are creating this vortex of wind right here, we get that cloud formation. So the reason why these clouds are dangerous is because we're going to have high winds, and they could come from any direction, right? We could be on this side, and it'd be coming from the mountain side, the leeward side there, or we could be up here, and it could be coming from the opposite direction than the wind that we experience right here, right? So the wind could be variable, but then it's extremely turbulent. It's going to throw you around. Okay, if we're coming over the top here, and let's say that the airport's down here in this bottom corner here. Okay, what we could be experiencing as well is we'll get these vortexes in several spots, and what it does is it creates what we call wave turbulence, where it feels like we're riding a wave. Okay, sorry, messy 2-year-old drawing computer on the computer skills. But so altocumulus, standing lenticular, ACSL, pretty important to know about because of the turbulence and the high speed winds and the wind shear. Towering cumulus would be the TCB, and then CB. So all associated with high speed winds, probable, or turbulence, or a combination of the two. So you can see here, although we have cumulonimbus clouds, they're only expecting 5 knots of wind. But I'm sure it's going to be bumpy. Okay. All right. Well, let's see. It's already, time flies when you're having fun. It's already 7 o'clock. Why don't we take our, do you guys want like a 15-minute break, or do you guys want like a 30-minute dinner break?
Dinner break.
Sorry. Where do you guys feel like you're getting most confused with these TAFs? I mean, they're pretty much a METAR, right? As far as being able to read them.
Yeah, I think just repetitiveness on it just to kind of get it down. Other than that, I think I'm
Okay. So I'm going to pull up the METARs as well with this. Because if you can get METARs down, TAFs are a walk in the park. Where TAFs start to get hard is legal to go and do I need an alternate. So let's go through METARs again. And let's see what you guys can remember. So I'm going to start at the top of the list here, and we're just going to go down. Don't feel like you're dumb for missing things, because you most definitely are. I mean, you guys were introduced to the material yesterday, right? So, you know, and like I said before, I still like have to look up these abbreviations myself sometimes, depending on what they are. So I want you guys to don't feel like I'm picking on you. Don't feel like I'm, you know, just out to get you or make you feel dumb or nothing like that. It's practice, right? Practice makes perfect. And
I don't need to feel dumb.
so
I do that.
So remember that this isn't something that you're going to perfect just in class as well. What I want you guys to do, did they give you the link to the abbreviation page where it shows you all the abbreviations and what they mean?
No.
That was one of the pages that we could download off of the site yesterday, I believe.
What was that?
I think that was one of the pages that he posted yesterday for us to be able to open up.
Oh, okay. Well, I'm gonna post a page that I like. This program drives me nuts sometimes. What?
Isn't it that document over on the right-hand side with the link?
This one?
I was thinking it was the one next to it, to the right. Where you were.
This one?
Yes.
Okay. So this is one of them that you guys can use. I'll make it so you can, so it's a hyperlink, but this is also very, very important. I strongly recommend you guys like actually read this document very carefully, because this is going to help you out so much. I know it's long, but Adam has highlighted all these different sections that are important. Pay special attention to those, and those are the ones that we want you guys to really. The other stuff is information, but this is like important practical stuff. So one thing that I want you guys to do that will be required of you guys, whether it be an interview or practical everyday application, this chart right here is very, very important, because this is your precipitation. This is the descriptors, the intensity, the obscuration. This is what you're going to have. I mean, this is pretty much what you need to know. The The cloud layers are easy to read. The visibility is easy to read. The time's easy to read. The wind's easy to read. This stuff, you just have to commit to memory. So I strongly, strongly recommend you guys commit this right here, this chart, to memory. Okay. As far as this link goes, I'm going to add another reference for you. This Moratech is kind of nice as well. So either one of those is going to give you the same information. But this just lays it out nice and easy for you. So if it's in the sky conditions section, this is all the sky conditions that you're going to see, okay? If it's a remark, here's your different remarks. And then these encoded groups, this is in the remarks section. This is just like the 6 hourly maximum temperature. This is the, you know, the blocks of numbers at the end of the METAR. This is what they mean, and this is how to decode them, okay? And then this is just a list of other abbreviations that might randomly pop up. And this is where I have to go back and refer to this list, because there is no way in hell I'm going to remember all of those, right? Like, look at that, extreme, extremely. There's no way you can memorize all 1,000 of these and just, I mean, you could, but it would just take a long time. And is it necessary to memorize all of these? Probably not. So I just recommend that you have the basics down of how to read it, meaning you have this down, and then this is all just extra information that you might see. One thing that's easy to do here is, let's say you want to look at what does RGD mean? Well, just do a Control F or a what is it on the Mac? Command F, and do the search box, and there you go, rugged or ragged. So if there's something in a METAR you don't know what it is, let's see, ADV CTN. There you go, advection. Okay, that's what's going to help you guys identify these different remarks sections. You know, going back to the Google Drive here and looking at these METARs that they gave you. You know, RAB 50. What does that mean? Cody, do you know? RAB 50.
Oh, I was muted. I'm not sure.
Okay, so what does RA stand for? When in reference to a METAR. You can see it right there as well.
Rain?
Yeah, so rain.
Oh, there, duh.
You're good. So I'm going to teach you guys a quick trick with this. Okay. When you're looking at a METAR, this remarks section is just a more in-depth reading of what you see in here. So the remarks are just You know, we see a temperature dew point spread right here. Okay. Well, in every single METAR, you're also going to have the same right here. But what's the difference? This is a more accurate temperature reading of what you see here. So temperature, 18.3 degrees. You'll see it in a four numerical, I don't know how to say that properly, but it'll be 4 digits, or four, yeah, 4 digits, okay? So this T identifies that it's the temperature dew point spread, the accurate temperature dew point spread, 0183, 18 degrees, okay? It's just rounded to 18 degrees. 0139, 13.9, 14 degrees, okay? So every time I'm looking in a METAR, if I see something funky or unusual up here, like thunderstorms and rain, okay, let's look at this one for that example. So rain, thunderstorms, okay, and then I get this weird ONCL LTG IC, okay. What in Sam Hill does that mean? I have no idea. So I refer back to what I see up here. I see rain and thunderstorms. Well, I can kind of guess and go OCNL. Okay, that's maybe occasional. Okay, then I see LTG. Probably something to do with the thunderstorms and rain, lightning. Okay, IC means in cloud. Okay, so this is just describing what kind of lightning we're seeing associated with this thunderstorm. Okay, and then north, TS, north, move northeast. So the thunderstorms in the north are moving to the northeast. Pretty good guess. TSB. Whenever I see a B, I always think began. So thunderstorms began 20. Whenever I see numbers after an abbreviation there, I always start thinking time. So thunderstorms began 20 minutes after the hour. So a lot of this is what is the word? Like practical, it's, what is the word I'm thinking of? Intuitive. Okay, it's intuitive. You just got to start thinking like a weatherman. So just remember that the METAR is giving you the basic, the meat and potatoes of the information that you need. This is the most important information you need right there. Okay. As for the remarks, it's just helping you understand why or what is going on up in this main meat and potatoes. So it's just giving you additional information to support this main line. As for stations, it will always, the remark section will always start off with what kind of station is reporting the weather. So do you guys remember what an AO2 is? Rex, do you remember?
It's a moisture capable. Is it AWOS or ASOS system?
So it's automated observation with precipitation discriminator. So it just means that it has the ability to determine what type of precipitation is falling. Some METARs, if you see an AO1, it could be raining, it could be sleet. It doesn't understand the difference between the two. It'll just give you information saying, hey, there's moisture out there. There's precipitation falling. I don't know what kind it is. So I don't see a whole lot of AO1s anymore. I see more of the AO2s. Like, not only do I see more, I see way more AO2s than AO1s. It's very rare to see an AO1 anymore. And so whenever we see the AO2, we just automatically think, oh, hey, that can tell me whether it's rain or snow or sleet or hail or ice pellets, snow grains, whatever the precipitation may be. It can discriminate and tell me what it is. Okay. And then, like I said before, this is all just giving me more information to support the statement here. Okay. Thunderstorms began 20 after the hour with occasional lightning in cloud. To the north, thunderstorms north moving northeast. And then this is the amount of precipitation that's fallen in the last 6 hours. You just put a decimal point right in the middle there. 0.01 inches of rain have fallen in the last hour, or last 6 hours. Sorry. Temperature is 6.1 degrees, or you can see there, 6 degrees. And then the dew point is 4.4 degrees, or as you can see there, 4 degrees. So it's, like I said, it's intuitive. It's just, you got to remember that if you're getting confused at what you're seeing in the remarks section, try to make sense of it by looking at the main body of the METAR. So, does anybody remember what the $ means?
Maintenance.
Yeah, so the station just needs maintenance is all. So it's just flagging the FAA to say, hey, this station needs a little oil change, So if you guys have the ability, if you guys have a phone or an iPad or something of that nature, pull up that Moratech link that I posted. Let's see, I still have it here? Yeah, I'll post it in the comments here if you guys need it in the chat window. Okay, and then we are going to go through some METARs. And I'm going to go through, everybody's going to decode a METAR. And we're going to walk through it. I want you guys to just try your best, right? If you guys don't know, that is perfectly fine, okay? It's what I want you to do, though, is I want you to struggle through it. I want you guys to think about it and just kind of walk through it. Try to make sense of what's on there. So, starting at the top of my list, I have, every time I click on my sidebar, my control panel, I get my screen shifts. Maybe if I minimize this and then just extend it out, it'll stop doing that stupid thing. All right, so Cody, you're up first. I want you to start right here and just go for it. You know, just try your best. No problem. I'll help you. I'll walk you through things. If you've got that METAR decoder pulled up, that's going to help you out. So,
all right. So on the 23rd at 2354 Zulu, 180 at three nautical. Oh my gosh, totally just went blank on that one. 3 nautical miles. 10,000. My gosh, hold on. 10,000 standard or 10 standard miles visibility. Broken clouds at 22,000 feet.
wait, what line are you reading?
Oh my gosh, I'm doing the one above that one. Wow. Never mind. How special am I on that?
No, you're good.
Let's start over again. All right, 23rd at 2054 Zulu, 180 at 3 nautical miles. Oh yeah, sorry, 10 standard miles or 10 miles visibility. The well, I'm sorry, I'm doing it backwards. At 5,000, there are towering cumulus. Let me see, and then that's right, and then that's a few towering cumulus. Is that what that is?
Yeah.
FEW?
So few. So let's talk about cloud cover real quick. So we'll have skies clear, which means there's no clouds overhead. When we see few clouds, that means that I want to say, let me get an accurate number here. Okay, so few clouds means that there's 0/8 to 2/8 of the sky is covered in clouds. Okay. When we see scattered, that means 3/8 to 4/8. When we see broken, that means 5/8 to 7/8, and then overcast means that there's just a solid layer of clouds. So it's just stepping up how much of the sky is covered in clouds. So few clouds, that's why few clouds, few and scattered, aren't considered to be a ceiling, because there's still plenty of the sky that's open. Like less than half the sky is covered in clouds. But once we hit that broken layer, that means about, anywhere from half to 3/4 of the sky is covered in clouds. Well, half to 7/8, right? So most of the sky is obscured with clouds, and then overcast just means it's a solid layer. So there is absolutely no blue coming through, right? So that's why it separates it into these different categories. Is you want to see where each cloud layer is. So, sorry.
No, we're good.
So you read it right. Few clouds at 5,000, towering cumulonimbus.
And then scattered clouds at 10,000, broken at 11,000.
Correct.
And the temperature is 21 degrees Celsius. Dew point is 9 degrees Celsius. The altimeter is it 29.95?
Yes, perfect.
Okay. And then, oh man. SLPN. I gotta go search through all this.
No, you're good.
Oh man.
So do you have the Moratech opened up?
Yeah, I'm just
Go
trying to figure
to,
out what it is.
yep, go to the other section. You've got your weather identifiers, modifiers, and then others.
Okay.
And it's in there.
Oh, okay. So, oh, the sea level pressure is not available.
Mm-hmm.
PK, so there's peak wind.
Yep.
So sea level is not available. There's peak wind. And then that is, oh, where did I have it written down at?
So this is telling us what time did we experience the highest speed wind and how fast.
Oh, that's right. So on the 23rd at 2700 and the 23rd at between 20.
Close.
Or, sorry.
But it's going to identify the wind speed. So.
Oh, okay. Sorry. 230 at 27 knots, and then at is that the date and the time at 23?
Uh-huh. So that's it, 2320 Zulu.
Okay, 2320 Zulu.
Mm-hmm.
And then it's got rain. Oh my gosh, REB. B is so sad when I know this, and then when I go to read it, I can't read it.
You're good. No worries. So that's at the very, very top in the first section.
So rain began at 23 minutes after.
Uh-huh.
And then that, I don't know, it's E estimated, not E estimated. Ended at 46 after.
Exactly.
And then there was a cumulonimbus, I don't know, DS. I don't know, a DSNT at east, southeast, and west. There's a where's that? There's a towering cumulus, east, southeast, and west, right? But I don't know a distant.
Yeah, exactly.
Okay.
So we've got cumulonimbus clouds distant at the east southeast quadrant and in the west quadrant. Okay. We've got towering cumulonimbus clouds in the east, shifting, showers in the vicinity east and west. Okay.
My gosh.
It's like I said, these METARs will kick your butt, and it's like I said, I'm still frequently looking up some of these remarks sections. I still have to look up some of this stuff because it's hard to understand. So when it says sea level pressure, not what is it? Sea level pressure
not available.
Not available. What it's saying is that the sea level pressure reading device isn't working at that point. So it'll give you an accurate sea level pressure. Let's see if we can find it down here. So this sea level pressure here this is giving us the sea level pressure in millibars. Okay, so this is an accurate sea level pressure, whereas this altimeter right here, this pressure, this is given to us in inches of mercury. This one's given to us in millibars. Does that make sense? So when it says sea level pressure, not oh gosh, not available, what it's saying is that this sea level pressure, I'm sorry, it's saying that during that hour, that wasn't working. That part of the machine wasn't working. The millibar conversion part wasn't working. It wasn't giving out a number. So, no, you did really good though. That's exactly what I want to hear is people struggle through it. So, some things to clean it up just a little bit. Remember that when we read our winds, we're this nautical miles. We don't read it in nautical miles. Knots are the conversion from a distance to a speed. So the wind is coming from the south, 180 at 3 knots. So when we say knots, we're referring to the speed. Nautical miles refer to the distance. So we just read it 180 at 3 knots. Okay.
Okay.
And then this 10 miles is sufficient. The S, just remember, stands for statute. So we just read it as 10 miles of visibility. And that's sufficient. So no, but you did really good with it. That's exactly what I want to see. So let's see, Elizabeth, why don't you take a stab at that one?
All right. So Salt Lake City at 23:20 or on the 23rd at 20:54 Zulu. 30 degrees.
Uh-huh.
I've been struggling with that one. Are we thinking of it in terms of a compass and the wind is coming from the 30-degree mark?
Yes. So that's always our headwind. The wind is coming from 030 degrees and heading the reciprocal of that, which would be 210 degrees. So 030 to 210. Did that help? Or did that add confusion?
Yes, I've been wondering what this degrees was about.
Yep. So you have 0
all
here.
kind of feels about the same.
Yep. You have 0 there, 3 degrees, 30 degrees there, 90 degrees, 120, 180, and so on.
Mm-hmm.
So it's coming from 3 degrees, and it's moving to the southeast, or I'm sorry, southwest. So northeast to southwest. Okay, good.
Okay, traveling at 8 knots
Uh-huh.
for invisibility is 10 statute miles. 1 second, I'm looking up SCT. Scattered thunderstorms?
Nope, just scattered clouds.
Scattered clouds at 7,000 feet cumulonimbus.
Uh-huh.
Broken at 10,000, no.
Uh-huh.
Yeah, broken at 10,000, and then again at 23,000.
Uh-huh.
I don't quite know how to read the next part. It's a dew point of 17 degrees.
Nope. So this is temperature and dew point.
So it's 17 degrees Celsius.
Yep.
With a dew point of 11, which probably means it's pretty humid.
So 11 degrees Celsius. So what it's saying is is at 11 degrees, the moisture in the air will become saturated. The air won't be able to hold all the moisture in. Does that make sense? So that's when our temperature and our dew point spread come out to be the same, say 11 and 11 degrees.
Mm-hmm.
The type of weather that we associate with a temperature dew point spread that is the same is fog, right? So that just means that the air has become 100% saturated. So it doesn't necessarily have anything to do with the humidity level. It just is saying that at 11 degrees Celsius, the air is saturated. Can't hold any more water. So we start seeing things like fog.
My brain's having a hard time with that one because it exceeds that number. So what does that mean?
So that means that this 17 degrees here, it means that it's warmer. So it basically what happens is it's clear, right? It means that if this temperature drops to 11 degrees, then the air will become saturated and we'll see things like fog. But anything above, there is still room. Like, how do I explain this? The temperature is too warm for the air to become 100% saturated. So we won't see any of that fog or anything like that. It'll still be clear skies, basically. It's just when they converge and equalize, that's when we've reached 100% saturation in the air. I don't know how to explain it any other way. Does that make sense at all?
No.
Yes and no.
Well, I guess in my mind, either it's humid or it's not. And what's the percentage of humidity? I've never really considered fog to be a variable. But that's because I lived in Ohio and I live in Arizona, so it's either humid or not.
well, so humidity, like I said before, doesn't have anything to do with this. Humidity levels are very different.
So humidity is not related to dew point.
No.
Oh, okay.
Okay.
Oh, okay.
So
it's a different thing altogether.
So you have, I'm going to put a bunch of little red dots here, okay? So we've got this column of air, okay? Or as we refer to it in aviation, we have a parcel of air, okay? The red dots are oxygen molecules, and these blue dots are going to be water vapor, okay? So what it's saying is that once the temperature equalizes and the dew point and the temperature are the same, what's happened is these blue dots and the red dots have equalized, and the air can no longer hold the water vapor in anymore. So all of a sudden, we have visible moisture. We have the fog. Does that make sense? So the water vapor and the air molecules have equalized to the point where we now have that visible moisture present. The air can't hold the water vapor anymore.
So is it like it's gonna get fog or like rain?
No, just
fog.
Just fog. Because it's just all the air around us, and when it takes this temperature, This is taking it at the surface. And so it's what's going to, when we see them converge, that's what's happening at the surface. The water molecules, and what is a cloud?
Moisture.
Yeah, right. So what is fog?
Baby cloud.
It's a cloud on the ground, right? It's in contact with the ground. So basically, it's the same exact thing. The temperature and dew point spread, we can actually use this to determine what level we'll see the clouds. So if we take the adiabatic lapse rate, depending on if it's a moist or a dry adiabatic lapse rate, we can determine at what level we'll see the clouds. So as we climb in altitude, remember our standard lapse rate is 2,000 or 2 degrees per 1,000 feet, right? That's our standard lapse rate. But we have things like moisture and things like that that'll change that, whether or not it's 2 degrees or 1.5 degrees or 3 degrees. That's subject to change. But for sanity's sake, we're always going to use 2 degrees. In this class, we're going to use 2 degrees per 1,000 feet. So we can figure out what level we're going to hit 11 degrees. So if we take 17 degrees, what's the difference between 17 and 11? 6 degrees, right?
Mm-hmm.
So we've got to climb 3,000 feet and we would start seeing the lowest layer of clouds. Does that mean that that's going to hold true 100% of the time using the standard? Heck no. So this is probably a dry adiabatic lapse rate of 1.5 degrees per 1,000, which would put us about at that scattered 6,500. But to figure out whether we're using the dry or moist adiabatic lapse rate, we've got to figure out a couple other things that we're not even going to talk about. But yeah, the temperature dew point spread, when they converge, that means at the surface, we're going to have visible moisture, which is going to show itself with fog. So basically a cloud on the ground. But like I said, you can actually figure out at what level the clouds are going to be with that temperature and dew point spread.
And dew point is not humidity.
Dew point is not humidity. It's the
the point for clouds?
It's the point where we'll see visible moisture. What temperature we'll see visible moisture.
Okay.
So yeah, like I was saying, we can figure out the level of the clouds using this, but it doesn't mean that that's humidity. It's not associated. Because I can tell you right now, like in Salt Lake right now, it's probably like 20% humidity. It's not humid here right now. So yeah, I mean, it's not associated really at all. It's just at what temperature are we going to see visible moisture because the air has become saturated. Saturated meaning heavy with water vapor. I don't know how else to explain it. And we can get into super complex scientific terms of how this is all figured out, but it's not necessary. And your brains are going through enough right now, enough trauma. So I'm not going to go into it, but what you need to know is the basics of what you need to know is that when those two numbers converge, we'll likely be seeing fog on the ground. So that's why those numbers are there. So I had you on this one. So keep going past the temperature dew point.
So the altimeter reads 2996. Where should the decimal be?
In the center.
In the center.
Mm-hmm.
So 29.96 inches.
Yeah, so 29.96 inches of mercury. But we just read it altimeter setting of 29 or 9 or 6.
29 or 6.
Yep.
Okay, now I gotta get out my cheat sheet.
Mm-hmm.
Thunderstorms began 25 minutes after the hour.
Okay, what does the E stand for?
Is that after?
Ended.
Ended.
Mm-hmm. So the thunderstorms,
Ended.
if we look at the previous times,
Mm-hmm.
We may see a thunderstorm began, but that's just saying that there were no more thunderstorms 25 after the hour.
And rain ended at 49 minutes after the hour.
Mm-hmm.
Virga.
Yep. So what is Virga?
There are Virgos, the zodiac sign in the distance.
Yeah. Almost.
It's a capital Virga, and then it just has lowercase Virga as a definition.
So yeah, so here's our cumulonimbus cloud. Okay, and here I'll change my pen color. I'm gonna make this pretty for you guys. Here's the ground. We've got a tree here. Friendly little tree. Happy little tree. And we're gonna put a little happy little bush here. Okay. Anyways, okay, enough Bob Ross. Okay, Virga is those little light wispy clouds that drop out of the bottom of the clouds.
Okay, so those are in the distance.
Yeah, so these clouds that have the Virga are distant northeast. Okay, so Virga, remember what Virga is? It's rain that's falling but not reaching the ground. It's evaporating before it reaches the ground. Okay?
Mm-hmm. The cumulonimbus ma'am. Less than, right? The M of that is less than?
No, I think this one is different. I think MAM is an abbreviation all by itself.
Okay, I'm looking for it. I am not finding it on this sheet. Unless I'm missing something.
Okay, it is two separate.
So less than. Don't have an AM.
This is the first time I've ever seen this abbreviation.
Are they cloud shaped like women?
Yeah. So I'm looking it up right now. So antimeridium is a meridium at 180 degrees from another meridium opposite the prime meridium. Antimeridium, normally abbreviated for morning. That's weird.
How do I interpret that?
Let's memory.
Clouds.
That's AM. Oh, that's meridian. Let me see meridium. Everything that I see points to it being AM, but that doesn't make sense. See?
I found it.
Yeah, I think I just found it too. Go ahead.
Cumulonimbus mammatus.
Mammatus.
Those are the nastiest type of cumulonimbus clouds with the most violent turbulence.
So I'll show you what they look like.
Where did you find that?
It wasn't on any of these sheets. I had to go online.
Okay. You said cumulonimbus nomatus?
Mammatus.
Mammatus. The mother of cumulus clouds.
Yeah. So do you guys see these? They're like droopy. It's like foam, is what it looks like to me. Some of those aren't very good. So I saw these today. And what happens is these are kind of like precursors to tornadoes and stuff, from what I've seen. You see these clouds, and then you'll see there'll be like this seafoam green in the clouds. So these will just be black, and then you'll see this seafoam green around them. And that's pretty indicative of like a tornado. So, yeah, pretty violent clouds. This kind of shows you some of that I'm talking about, but it's not as clear. I'll take pictures of it if I can see it again. Hopefully I'll be able to see it again today.
So those are moving overhead northeast.
So overhead moving northeast.
And then there's another cumulonimbus moving northeast and southeast moving northeast.
So there's a cell that's northeast and a cell that's southeast that are moving northeast. So there's a cell, let's see. So here's the airport. There's a cell to the northeast and a cell to the southeast, and they're moving this direction.
I have a question about the the CBMAM.
Mm-hmm.
Let's say that I'm dispatching a flight and this is the first time you saw it. If you were at work, would you be able to Google it, or would you go ask your supervisor?
Yeah, I could Google it if I wanted to. But I'll tell you right now, it's not going to affect how I dispatch the flight. So, remember, these are METARs. So, METARs, what currently is happening? We don't really dispatch to cloud types because we don't know what's actually going to be occurring at the point that the plane actually gets there. So you can see that these cumulonimbus mammatus, or mammas, cumulonimbus mammas, are only occurring during this METAR, during this hour, right? You don't see them the hour prior or the hour after. So we can't really dispatch according to a cloud type. So really, technically, we don't look at this too much as far as dispatching to an airport. When this would come into play is, let's say that all of a sudden Chicago has thunderstorms and we're looking at the METAR for what's going on in Chicago right now because our flight is 20 minutes out. And we see those cumulonimbus mammatus. What we do is we just say, hey, we got some CBMAMs in the vicinity of the airport. They're currently overhead at the airport. Expect turbulence. And that's all we could do. Just notify the pilot, hey, this is happening right now, so it's probably going to be pretty turbulent going in there. And that would be the best that we could do. It's giving them a heads up. But as far as planning the flight, remember that when we are dispatching these flights, we're typically sending the dispatch release. So we've completed it and we've sent it to the station 60 to 90 minutes prior to the flight even leaving the ground. So things change really fast. And, let's say we're doing the Salt Lake Chicago flight. That's a 2.5, 3 hour flight. We're looking at weather that's 5, 6.5 hours, 7 hours out. And, this METAR isn't going to pertain to what is actually going to be happening. We can use it as reference and just, but that's strictly what it is just reference. The METAR at that point is just a reference as to what we need to be looking for when we plan the flight. So if we look at like here, you can see how quickly this weather will move, right? So here's Salt Lake right now. That's kind of a bad example. Take this cell, for example, how quickly it grows over that time period. It's really hard to see with the lag in the video, but you can see a rapid change in the cloud and the precipitation that's falling. So, the point is that this is when we push play on this weather here, it's taking snapshots of every 30 minutes. So every 30 minutes, it takes a snapshot. and you can see where the clouds are moving. And so that weather is constantly changing over an area. Like today in Salt Lake, we had some really nasty cumulonimbus, towering cumulonimbus. We even had, like a supercell move over the top of us, where it was just huge, widespread, towering cumulonimbus cloud that just dissipated, but it was just massive. Uh, it just changes extremely quick, because that was there 15 to 30 minutes later, it was gone. No more rain, nothing. So it changes really rapidly. That weather can be affecting a field and then just be completely gone by the time we get to it. So so we just dispatch to the TAF at that point. So we'll look at the TAF, and when we look at a TAF and we're determining legal to go, we're just going to go over this really quick, and then we'll get back to the METARs. We're going to say our ETA is, for Portland here, our ETA is going to be 0530 Zulu, okay? So what we're going to do for legal to go is we're going to come here at 0530, and at Portland, their runways have ILS, and their minimums are 200 feet for the ceiling and half mile for the visibility. This is a standard ILS minimums, right? So we would take a look at this half mile visibility. We don't even care about the ceiling. That ceiling's going to change by this is just a forecast and an estimate at what they expect the ceilings to be doing. Doesn't mean that that's what's actually going to be occurring, and we don't know. It's a broken layer. Maybe the approach end of the runway is that 3/8 that's open clouds, where there's nothing. It's just clear skies right at the end, approach end of the runway. But maybe it's the part that is covered in clouds. We don't know what's going to happen, so we just don't even take into consideration the ceiling. We look at the visibility here. Okay, so if it is above a half mile visibility in the TAF, then we're legal to dispatch at our ETA. Okay, that's the only thing we consider when we're looking at our TAF is, do they expect us to have at least a half mile visibility? Yep, 6 miles, greater than 6 miles of visibility, we're legal to dispatch. Okay. The next thing that we look at is we look at, do we need an alternate? And what's the requirement for an alternate? Eric, what's the requirement for an alternate? When are we required to list an alternate on the release?
Is that the 1, 2, 3 rule?
Yeah, so always, unless 1 hour before, 1 hour after the ETA, we have 2,000 foot ceilings and 3 miles of visibility, right?
Yep.
Okay, so we'd look at this part right here and we go, do we have 3 miles of visibility or greater? Yep, we sure do. We have greater than 6 miles of visibility. Then we'd look at this, where's our ceiling at?
It's a broken layer, right?
Yep, the broken layer at 6,000, exactly. So this is our ceiling. We don't even care about this. This doesn't mean anything. Okay. So we'd look at this broken 6,000. Is that greater than 2,000 feet?
I think so.
Yeah. So do we require an alternate?
We don't.
No. So remember though, in this line, we don't require an alternate. But we got to look at the hour prior, right? So we have to look an hour ahead, and we got to look an hour before. So does that 0530? So what's we call it an ETA window? What is our ETA window? Hour before, hour after. So 0430 to 0630, we have to have that 3 miles and 2,000 foot ceilings, right? So this forecast is for 0500. So from 0500 down to 0859, this is what the weather is expected to be doing. So since 0430 falls prior to that, we need to take into consideration this line as well. Do we have greater than 3 miles of visibility?
Yeah, it's still 6 miles.
Okay, still 6 miles. And do we have greater than 2,000 foot ceilings?
Yep, it's 12,000.
Exactly. So we do not require an alternate at all. Okay. So we could just list Portland as our destination. No need for an alternate. Don't have to plan alternate fuel or anything like that. We're good. We're legal to dispatch, and we don't need an alternate. So we'll talk a little bit more about that, and I'll actually have you guys do dozens of worksheets that I've already created for it to help you get familiar with legal to go and alternate required. So, all right. So Eric, since I was picking on you, I'm going to pick on you a little bit more, I think.
All right.
So,
You know, huh?
Yeah.
All right, so it's the 23rd of the month at 20:55 Zulu. The wind's coming in at 320 degrees at 8 knots. There's a 10 statute mile visibility, a few clouds at 6,000 feet, scattered cumulonimbus clouds at 7,500 feet, scattered clouds at 11,000 feet, broken clouds at 15,000, broken clouds at 22,000. The temperature is 23 degrees Celsius, dew point 7 degrees Celsius. The altimeter is 29.93. So for the remarks, lightning in the distance to the southeast. Thunderstorms ended at 6 after the hour. SLP is sea level pressure, which is that just 90?
Yeah, so 90, well, it's really 900 millibar. So,
900. And Virga, that's the rain below the clouds, that like the wisps of rain that you can see that dissipates before it hits the ground.
Yep.
Cumulonimbus, west, it's to the west, moving northeast. And then there's another cumulonimbus in the distance. ALQDS. Definitely got to look that up. All quadrants. So there's clouds in all quadrants, I guess.
Yep. So the entire area is surrounded with these cumulonimbus clouds in the distance.
and TPG. Looking it up. Topping. So topping above the mountains. Okay, so in all quadrants, there's clouds just above the mountains, at the tops of the mountains.
Nope. So this one's kind of different. So this is one. So you've got cumulonimbus to the west moving northeast. Then you have cumulonimbus distant in all quadrants. And then this is saying clouds are topping the mountains distant to the southwest.
Okay. And the temperature is 23.3. And then dew point is 6.7. And I don't know what those last numbers are.
Okay. So this is one of those ones that's in the, if you look at the encoded groups, okay, we'll see it there.
All right, let me see. Is that the 6 hourly maximum temperature?
Oh, so it starts with the 5.
Oh, I see. So 3 hourly pressure tendency.
Mm-hmm.
Is that the PPP part of that too?
So so what it's saying is that there's been a steady pressure change.
Okay. Over a 3 hour period.
Yeah. So that's it. If so, okay. So what it's saying is that's giving us a intense how much the pressure change has been. So it's the 4 equals steady, but it's just saying that there's been a steady pressure change. So if it has anything but that 004, then it's just intense. Or if it has a 0, 1, 2, 3, it's steadily increasing. If it has a 5, 6, 7, 8, it's steadily decreasing. And then the higher number faster recently. So basically all it's saying is that there's been a steady it's the pressure's been steady over the last hour. Does that mean anything to us? Do we care?
I don't think so.
Hell to the no. So pressure, the only thing that we really care about with pressure, and the only time that I would ever even look at that is to simply go, is it stable? Is it unstable? Am I in a high? Am I in a low? But does that really affect how I'm going to plan the flight? Probably not. That's something that we just can't. The pilot's just going to have to deal with regardless. You know, it's nothing that we can do or change our flight plan. There's nothing we can do to change how we plan that flight for pressure changes because they just happen all the time in every direction. So yeah.
How does it actually affect the flight? Isn't it like less pressure, more power the plane uses to have to stay in the air?
Yeah, so the pressure, remember, is going to determine our pressure altitude, and then with our pressure altitude, we can figure out with the temperature, we can figure out our density altitude. So when we look at our pressure here, let's just use the altimeter setting, right? 2993. That's pretty close to standard sea level pressure. So for every 0.1 change in pressure, that's going to be, if it's less than sea level pressure of 2992. So if it's, let's say, 2983 or 2982, then we would add 1,000 feet to our altitude. If it's more than, so 30.02, then we would subtract 1,000 feet from our altitude at the field. So Reno, let's say Reno's at 3,000 feet for the elevation. Our pressure altitude with this would pretty much just be 3,000 feet. It's a difference of 0.01, which means a difference of 100 feet. So it'd be 3,100 feet. Or I'm sorry, 2,900 feet. So with 2,900 feet, then with our temperature of 23 degrees Celsius, standard temperature at 3,000 feet would, we remember from sea level, we take away 2 degrees per 1,000 feet. So we'd have to take 3 degrees off of 15, which would mean that our standard temperature is 12 degrees Celsius at 3,000 feet, but we are 11 degrees warmer. So being 11 degrees warmer, and with we would make the change. We'd take into account our pressure altitude of 2,900 feet, and then we'd go, well, it's 11 degrees warmer than that right now. So with it being 11 degrees warmer, we would have to add that that difference in altitude to our elevation, our pressure altitude, and that gives us our density altitude.
Okay, I think I understood the gist of that. So the pressure just really affects the altitude. I lost you at some point, but I think I get the gist of it.
Yeah, and we'll understand it a lot more. So basically, at the end of the day, is our altimeter is going to affect our pressure altitude, our temperature. We take our pressure altitude to figure out what our density altitude is. The higher the altitude, the higher the density altitude, because of the warmer it is, the less performance we get out of our engine. The more fuel we're going to burn, the less performance we're going to get, things like that. So,
okay,
super complex way of trying to explain it. I know. My wife said that I'm really good at like trying to feed babies meat before milk, you know. I dive too deep into the subject rather than just trying to make it simple. But no, you did good. You did really good. Let's see. Jeff, do you sometimes go by Hefe?
Sure.
All right, boss, here you go.
Weather in Shreveport on the 23rd at 21:56 Zulu, winds 280 at 9 knots, visibility 10 miles, few clouds at 4,800 feet, broken layer at 15,000 feet, broken layer at 24,000 feet, temperature 26 degrees, dew point 20 degrees, altimeter 2999, lightning distance southeast and south, thunderstorm ended at 48 minutes after the hour. Sea level pressure 153. Occasional lightning in the clouds. Not sure what CG is.
Cloud to ground.
Cloud to ground. Distant north. Thunder showers moving north. Cumulonimbus. Distant all quadrants. Temperature 26.1 and dew point 20.0.
Man, do you read automated weather reports?
I've heard them. Hey, I've got something that's kind of fun for the group. For an easy conversion you can do in your head for centigrade. It was a SkyWest captain that shared this with me, and I like it. Maybe you guys can use it. You don't even need to write it down. It's really easy. But any temperature that's above 0 degrees centigrade, if you take that temperature and double it, then add 30, and you'll get your Fahrenheit within a couple degrees. And I say that because if you take away 4%, you'll nail it. So when it's 30 degrees in St. George, if you double it to 60 and then add 30, you're at 90 degrees, minus about 4 degrees, you're at 86 degrees Fahrenheit. And that's when the temperature's 30 degrees centigrade. If you followed that. But it really is, I hope I didn't make it harder than it is, but it's really simple.
That's awesome.
Yeah,
I
just
appreciate
double it and add 30.
That's pretty funny. I once had someone from Argentina explain how they figure out Fahrenheit. And it was, think of the number as a percentage. So if comfortable is a percentage, then like 90 degrees, like you're maxing out. 120 degrees, that's entirely too much. It's not possible. You shouldn't be there. The opposite side is like 0. That's like the coldest thing you could possibly do.
There you go.
Yeah, I'm in Argentina, and I can tell you it gets hotter than I'll get out there in the deserts.
I bet.
Any hotter than St. George?
Easily as hot as St. George. We had a 53-degree Celsius reading one day.
Ouch.
And that went on for like not just a day, it was for a couple of weeks.
What's the hottest it gets in St. George?
Yeah. We got friends that did the whole Iraq and Afghanistan thing in the dead of summer. The numbers that they were spitting out, I was like, is that even possible? But
yeah, it's awful.
They say that the record temperature in Utah, Elizabeth, was 117 degrees. It happened to be the year I moved to St. George.
That's not so bad.
So,
yeah, I lived in not one-upping at all, but I lived in Apple Valley, Victorville, if you guys know where that is. But basically the high desert, we're talking Death Valley area. And yeah, we had a week where the temperature didn't drop below 110 degrees. The soles of my shoes literally melted. So I was out walking around, right? The soles of my shoes melted to where it was completely smooth. There was no tread on my shoes at all after that week from walking around. It was insanely hot. And that was also the week that our AC stopped working. So I would go to bed, wake up, and just, when I say a pool of sweat, I literally mean my mattress was saturated 100%, and I was just soaked. We were drinking like 2-3 gallons of water a day, and it still wasn't enough.
Are you saying that the temperature and the dew point in your bed was equal?
Oh, very much so. There was condensation on the window. No. No, it was disgusting how hot it was that week.
I never realized until just now what 53 degrees Celsius was. I just knew it was hot. I just translated to 127 degrees.
Oh my gosh.
It's Death Valley hot.
Yeah.
When I was a kid, my family and I were driving to California, and this was mid-afternoon, we arrived in St. George, and as we came in from the north, of course, St. George was smaller then. There was a Shell gas station, their sign towering kind of above the city line as we came in from the north. And I've got a picture to prove this, but it was 106 degrees that day, and the S on the Shell sign had fallen off. It literally said hell above the town of St. George. And we have a picture of that. I've got it. I'll have to show you.
That's awesome.
Yeah.
So, just kind of get back here. So, this lightning in cloud and then cloud to ground. You can also see this one here, right? No, this is not the Canadian hockey team. This is lightning in cloud, cloud to cloud, and then cloud to ground. So that's a fun one. Means that the clouds are just zapping everything in or around them. Pretty violent lightning storm. Thunderstorm. All right. Who wants to read the weather for Pensacola? Let's see, who's my next victim? Student. Okay, I can't. I don't know what's going on right now. Oh my gosh.
So I guess it's my turn.
Yep.
This is Pensacola.
Uh-huh.
So this is especially for Pensacola on the 24th at 0112 Zulu hours. The wind is traveling at 320 degrees at 6 knots. Let's see, 2.5. Not quite sure. Oh, 2.5 statute mile visibility. Then you've got vicinities of heavy rain and fog. A few clouds at 2,700 feet. Scattered clouds at 3,300 feet. Let's see. I'm not sure what OV BC means. Look that up real quick.
So that's in our weather identifier.
Yeah.
I'm sorry, sky condition. Sky condition.
Yeah, overcast.
There you go.
Overcast clouds at 4,200 feet. We've got a temperature of 22 degrees Celsius and a 19-degree dew point. Altimeter reading of 3009er. Lightning in the distance northwest. precipitation of 1.6 inches, and a actual temperature of 21.7 and 19.4.
Good. Yep. So this 2.5 miles visibility. So VC, vicinity, in the vicinity, TS, thunderstorms. So vicinity thunderstorms, okay? Or thunderstorms in the vicinity. So heavy rain, and then BR stands for mist. So kind of like fog, but mist. I can't remember the exact how they determine if it's mist or fog. I want to say mist is not as dense as fog. But I can't remember. There's like a percentage of obscuration that it's doing. So
Showing 5/8 on the weather reports page there.
okay, yeah. So it's reducing visibility by a certain percentage, and that's what determines mist or fog. Good. So heavy rain, that's a bad day. That's the one thing that I miss the most about Pensacola, though, was the heavy rainstorm. Like, I'm sorry, Utah does not get rainstorms like you get in Pensacola. Not even close. When it says heavy rain, that means that God opened up the fire hose and is spraying it directly on your head. So it's a little bit different. So let's see. Michelle.
Which city is MOB? Oh, Mobile?
Mobile, Alabama.
So this is for Mobile, the 24th day of the month at 56 Zulu. I don't know what COR is.
So just like up in the, or when we were looking at TAFs earlier.
Correction.
Mm-hmm.
Correction, winds from 130 at 9 knots. Visibility is 10 statute miles. Thunderstorms in the vicinity of the airport. Broken clouds. Broken cumulonimbus clouds at 2,800 feet. Broken clouds at 3,500 feet. Temperature of 25. Dew point 22. Altimeter 3007. Lightning in the distance of all quadrants.
Mm-hmm.
Thunderstorm began 32 minutes after the hour, ended 55 minutes after the hour. Sea level pressure 178. Frequent lightning in clouds east and southwest. Thunderstorms in the vicinity of the airport east and southwest, moving north. Cumulonimbus in the distance of all quadrants. The actual temperature is 25, and the actual dew point is 2.17.
21.7.
Oh, sorry, 21.7.
You're good. So awesome. Did way good. So I'm just going to throw in a little curveball here. What if we see a 1 right there or a 1 right there? What does that do to our temperature or dew point?
Makes it negative.
Exactly. What if I have an M prior to either one of these numbers?
Makes it negative?
Exactly. So the M in front of the temperature dew point spread here means negative, and the 1 right here or right here, so the very first number of the 4-number sequence makes it negative. If it's a 0, it's positive, 1 negative, okay? So we're not going to see that this time of year, but just to help you guys understand. Does anybody have a question on that?
Would it have hurt them to make it the same for both?
Probably. No, I don't know. I don't know. It's aviation. It's all messed up. So we would see it like, let me just edit this really quick. That's what it would look like if it was a negative temperature.
Can you have a negative dew point? I mean, what's that mean?
Yeah. So remember, the dew point is just at the temperature at which the air becomes 100% saturated with water vapor. So that's just the temperature. That's the break-even point, right? That's where we have just as much water vapor in the air as we have air. So
I gotcha. I went back to the whole moisture thing.
Humidity.
Yeah.
Yep. So it's given in a temperature, degrees Celsius. So yeah, that just helps you guys visualize it when you actually see what it would look like if it were negative. How's everybody feeling with it? Your brain's blowing up?
I feel good until I have to read it out loud.
Do you guys see why I'm hitting METARs again rather than just going on TAFs though? Someone read a TAF real quick. Let's see, who's my next victim? I mean student. Rex, go ahead and read that TAF for me.
I've got no idea what KIDA is.
Idaho Falls.
Okay, Idaho Falls on the 23rd at 23:24 Zulu. And is this part right here? This is good from 2400 hours or on the 24th from Euro Zulu until 24th, 24 minutes later.
No, 24. So this
hours.
one's an hour. This is 2400 Zulu. Yeah, so 24-hour window basically.
The winds are from 160 degrees, 9 knots. Sorry, my head's so full of. I'm looking at P6 statute miles. And just a quick question on the statute miles. And notice when it's unlimited or 10 miles, visibility could mean unlimited as well. Is this 6 miles here on the TAF because because the terminal area is only 5 miles wide?
Kind of. Basically, yeah. It's just meaning that it's probably going to be unlimited visibility. So the greater than 6 miles just means that you're going to be able to see a long ways.
Okay. And then light rain and showers. Thunderstorms in the vicinity, overcast at 7,000 with cumulonimbus clouds.
Yeah. So TAFs, like I said before, just they're METARs up to the temperature dew point spread. And let's just take a look at that. So this is our issue time. This is our wind speed and direction, visibility. This is the precipitation, right? This is the descriptor. And then this is the sky condition. So let's go back up to the METARs. So in Pensacola, this is our issue time. This is our wind speed and direction. This is our visibility. This is our descriptor, right? Our descriptor and sky condition. 100% the same. If you can read a METAR, you can read any TAF, because a TAF is going to be much less description of what they expect to be occurring. METARs and TAFs are read identically. The only difference is you've got to remember that the TAF is a forecast. Okay, it's a forecast, and that the forecast is broken into separate lines. Okay, the first line is a forecast for this time period. The next line is the forecast for the next time period, and so on. Okay. You just got to remember that this line starts at 0500 Zulu. So everything prior to that falls into this line. This line starts at 09. So everything prior to that, up to and including 0500 Zulu, is in this line. And so on and so forth. So that's the big thing. METARs, that's what's currently happening. TAFs, that's a forecast. That's our best guess of what will be happening in that time period. Does that mean that it's going to happen? Maybe. You know, this is like licking the dart and throwing it at the dartboard and saying, yeah, I think that's right.
So just to clarify, that 2400 over 2424 on that line.
Mm-hmm.
The 24th from 0 Zulu until on the 24th, basically be the last hour, 24 Zulu.
Exactly. So this is saying from midnight on the 24th. And like I said, they wrote this down for some reason. It's written weird, but the 24th at 24Z just means from midnight on the 24th to midnight on the next day, basically. So 24-hour window. So we call this a valid time. We'll also see that valid time whenever we see a tempo in our TAF. And let me see if I can find a tempo. Okay, so tempo, this is the valid time once again. So we can see that the TAF, you're always going to have a valid time on the first line of the TAF. And that's just telling us how long this entire TAF is valid for. Because, you know, we get to this 20Z line. How long is that 20Z line valid for? Well, it's valid until the 2400Z. So from 20Z to 2359, this line is valid. Okay. So it's not indefinite. It's just valid until the end of the validity time. So it's the same thing with a tempo here. This tempo is only valid from the 24th at 6Z to the 24th at 9Z. At that point, at 9Z, then this is our valid line. Or, in this case, at 2Z, because this isn't valid until 0300Z, at 2Z, we revert back to this line. This is, remember, this is called the main body. And then whenever we have a tempo or a prob 30, prob 40, whatever it says right here in right there, this is called the conditional language. Okay, so main body, conditional language, and there will always be a valid time for our conditional language. It's only going to be valid. They're just saying in this 2-hour window, we're going to experience light rain and thunderstorms, and the cloud layer is going to be at 5,000 feet, broken at 5,000 feet, cumulonimbus. Okay. But then after 0 to Z, it just reverts back to this. So that means that from 0200 Zulu to 0300 Zulu, this is, or well, 0259. That's the forecast. But you can see why it's so important to understand the METAR, is because the METAR and the TAF 100% the same. It's just the TAF is dumbed down, less information, because we don't know what's actually going to occur.
Now, we watched the METAR video yesterday. Did you want us to watch the TAF video today?
Yeah, that'd be great.
Or when we have a chance? I guess it's only a few minutes, right?
Yeah. So I'm going to, because this weather's really good, the METARs especially, I'm going to throw this all onto the Google Drive, just the same way that you guys have it on yesterday. I'm going to throw this into the on the Google Drive, and then you guys, with those two different websites, whatever one you like more, I want you guys to go through them and just practice, because that's what's really going to make the difference, right? Did I do this wrong? There it goes. It's probably going to post like 5 times, but okay, there you go. It's all in there. Yeah, it posted like 4 or 5 times. Anyways, that's okay. You guys can rinse and repeat. Okay. And I'll just copy this so that your links are right next to each other. All right, there you go. So here's some good practice, and here's your links to help you if you don't already have them open or don't have them saved. But yeah, really hit the METARs hard, because the TAFs are just going to come so much easier if you understand the METAR. Practice. Go through the exact way that we've been going through it. Just keep doing it. Go through line by line. The more you see it, the better you're going to get, the more fluent you're going to get, okay? But really get to know these METARs and TAFs. The next one that we're going to learn about is going to be PIREPs, and we're going to learn NOTAMs as well. Okay, those are extremely important for flight planning as well. So, and we've kind of touched them in the past, but we're gonna start. This is where we start getting into the practical dispatch application, right? This is stuff that you guys are going to use every day as a dispatcher. So learn it, love it, eat, breathe, sleep with this stuff. Get cozy with it. Are there any questions before we end tonight?